Let me write it again. Okay, so the idea is you want to separate the fraction into a sum of fractions. Usually we say you can't do this, but there is a theorem that says you can. So you factor the bottom, right, into two factors. And you get x plus 3, x minus 2. So these are different. That's what I mean by distinct. They are not the same. They don't repeat. They're unique. So when you have this scenario, there exists an A and a B such that you can separate the factors and add them together. And you have to solve for A and B, but that's how you set up when they are distinct. Okay, that's case one. So if they're different, just put A, B, and if there's like more than two, you put A, B, C, D, whatever. Case two. Repeated linear factors. So in this one, they start with x cubed minus 2x squared plus x. So first step is you factor the x out, right? And then you get x squared minus 2x plus 1, which factors into x times x minus 1 squared, right? So
whatever does is cube, is you gonna pull an x out, right? That's all.
yeah, they had a common factor. So pull out an x, and then I factor this quadratic into this. So this is no longer, this is a repeated, it's not distinct. These two are different, but this one repeats twice. So what you do is you go A over the first one plus B over the second one. So you start with the first factor, the first power, and you count up until the final power. So this one's 2, so you stop at 2. Does that make sense, how you set them up?
I got the A over X because we are separating the 2x minus 3 over x multiply x minus 1 all square. So A over X, B over X minus 1, I got it. C over X minus 1 square, I don't know from where this comes from.
So see how this is a square, right?
Right.
If it was a 3, you would do 1, 2, 3. You go all the way to 3.
Right.
That's the rule. So in order to make this equal, you have to count up to that power.
I see.
So this is a 1, right?
Okay.
Okay. And I'll show you, we're not going to solve them yet. Right now, I just want you to understand how you set them up for each scenario.
Hello.
Hey. All right, so that's case 2. Now let me post the, we're doing this file, where is it? So we're reviewing partial fractions, just in case people forgot.
There's no new lessons, right? Or...
Not yet. We're going to review this first, and then we're going to start the actual integration.
Okay.
So what I want you to see is why this is useful. Because when you first learn this, it's not useful. And most people do it in pre-cal or at the end of college algebra, around there somewhere. Lately, it's been in the beginning of pre-cal. But you see how if you needed to integrate this one, if you separate them, you can integrate these no problem, right? But integrating this together is a pain. You can't do it. But integrating these two is easy. So that's why this is useful, the partial fractions. So let's keep practicing. And then we'll move on. We'll go to the actual lesson. Okay, case 3 is distinct quadratic factors. So let's say you have this on the bottom. You see how you can't factor the quadratic part, right? It's not going to happen. So when that happens, you can call it, it's usually called either irreducible or unfactorable. So you have to deal with it. The first one is the same deal, right? It's still a over x minus 1. The second one, you have to write it this way. You write bx plus c over the quadratic term you cannot factor. That's the rule for this scenario, this case. Okay. Let's do another one, this time where it repeats. So see how these right here, they're not going to factor, right? That's a sum of squares, squared. So so you use the rule from case 2 about repeated. So you start with the first one, first power, ax plus b, because you can't factor this. It's not linear. And then you go to the next one, cx plus d, up to the next power. So 2, 1, 2. So that's combining rules case 2 and 3 at the same time as case 4. Do you have any question on these first four cases? The rules make sense? I just need you to remember them when we get to the homework. You need to set them up correctly and then integrate. So the integration might be easy, but the setup is what's important. All right, case 5 is the annoying one because it requires long division. So the rational expression is an improper fraction. Okay. Sorry, lost my train of thought there. So if the power in the top is bigger, then you have to do long division and then do the partial fraction step. So for example, this guy here is a third degree on top and a second degree on the bottom, right? It's 3 and 2. So when this happens, you can't use case 1 through 4, you have to do division. So what you got to do is divide into this. Do you guys remember your long division?
Yeah.
So just in case there somebody forgot, let's divide into a random number here. 5 into 495. So 5 goes into 4 0 times, so I can't do it. 5 goes into 49 though, 9 times, right? Then we do 9 times 5, which is 45, and then the sign switches. I need you to remember this pattern. You try to divide in here, you get that number, you multiply and switch the sign. Then you start over. 49 minus 45 is 4. Then you can't divide into 4, so you bring down the 5. 5 goes into that 9 times, right? And then 9 times 5, subtract, and you get 0 remainder. So it's going to be the same pattern here, except I'm going to divide only with this guy. But I'm going to multiply all 3 terms when I get my answer up here. So,
It's gonna
what's up?
be X.
Yeah, it's going to be x, right? I'm going to do my scratch work over here. So x squared goes into x cubed. How many times?
X time. So it'll be
Yeah.
1X.
1x. So you put the x there, right? That's the pattern. The algorithm says then you multiply all 3, right? So x times all 3 will be x cubed plus x squared minus, oops, I forgot something. Before you start these, you need to put a placeholder. I forgot. So see how there's no quadratic term on top? You got to put a 0x squared so you don't get confused. So I'm going to put 0x squared minus x plus 3. So now that'd be easier. So you distribute this guy here, you get x cubed plus x squared minus 2x, x cubed plus x squared minus 2x, but then you have to subtract, right? That's the pattern. You do minus after 45. So then x cubed minus x cubed is 0. 0 minus x squared is a negative x squared. Negative x minus a minus 2 is plus 2, so that is x, right? You'll be very careful with your signs. Now, x squared goes into negative x squared. Negative 1 times, right? Negative 1 times this. Distribute, right? So I'm going to do it over here. Negative 1 times the whole divisor. Just switch the signs, right? So we will get negative minus x plus 2. Bring down the 3 and subtract everything. So negative x squared minus a minus is 0. X minus a minus is plus 1. 3 minus 2 is 1. Now I cannot go any further, so that is my remainder, right? So this becomes x minus 1 plus the remainder over the divisor. Right, that's where decimals come from, right? That's how you do the division. Do you have any questions on this pattern? It's the same as this. All right, so then you do the partial fraction on this one, because we're not done yet. That's just the first step. So you set this up, and then you break this one into pieces. So 2x plus 1, let's look at this. I'm only going to look at the second one for now. So that will be x minus, or plus 2 times x minus 1, right? Yeah, which is going to be a over x plus 2 plus b over x minus 1. So then you solve these two to complete this piece. All right, so those are the 5 cases. So I'm going to go back to the first one, and we're going to solve everything to remind you how you find, because I haven't shown you how you would find A, B, C, D. Right now, I have only shown you how to set it up. That's it. Is any questions on the first 5 cases? Okay, let's go back to case 1 and solve it this time. All right, so case 1, we had 5 over x squared plus x minus 6, which became x plus 3 times x minus 2, right? Which we said is separated into this. So the way you solve this is start with this part and multiply both sides of the equation by your LCD. So the LCD is clearly x plus 3, x minus 2, right? So you're going to multiply this on all 3 terms. So here we go. So x plus 3 times x minus 2 times the first fraction x plus 3 times x minus 2 times the a fraction, and the last fraction, same deal. So then these all cancel, leaving you with 5, right, for the first term, equal to these cancel, x plus 3's cancel, leaving you with x minus 2 times a, x minus 2's cancel, leaving you with x plus 3 times the b. So then you distribute everything and group the common terms together. So I'm going to distribute backwards. Is that cool? That'd be ax minus 2a plus bx plus 3b. So then you group the ones that are x's and the ones that are not. by the way. Okay. So the technique I'm about to use is called equating the coefficients. So you factor the x out. And you remember that these are just constants, right? So the way you do this, you create a system. And you say, okay, these coefficients of x is equal to the coefficient of x on the left-hand side. Do you see any x's over here?
No.
So this would be equal to 0 because there's a 0x on the left-hand side. Now you do the constants. So that would be equal to the constant, 5. And then just solve the system, and we know a and b. I would recommend just use a matrix in your calculator because at this point I know all of you can do substitution and elimination, right? I believe in you. All right. So go to the matrix menu, second x inverse. Then go to edit, and I'm going to edit the first one. This is a 2 rows by 3 columns, so 2 by 3, 1, 1, 0, negative 2, 3, 5. Quit. So now it's saved. Go back into the matrix menu. Go to math. All these math operations are for matrices only. So press enter on RREF. Go back and pick A. So now it solved it for us. So this is going to be 1, 0, 0, 1. This is called row reduced echelon form, if you remember your matrix stuff. So this means that what? A is negative 1, B is 1. So the fractions will be negative 1 over x plus 3 plus 1 over x minus 2. This is the answer here. We decomposed this fraction into these two fractions here. That's what we're trying to do. That's the whole point. So any questions on how we set up the system? Where this came from, or any algebra steps? All right. Well, let's go back to Cal 2, right? Okay. All right, so this is 8.4, partial fractions. Decomposition. Okay. So in these notes, I try to simplify as much as possible because these notes assume you remember partial fractions, which may or may not be true. Okay. So if M proper, Okay, yeah. If improper, you must divide. And that's what I showed in case 5. So in these notes, if you have a numerator over some denominator, right? And the top one's bigger, degree is larger on top, then you do your long division and you end up with a polynomial plus the remainder, right? That's what we showed earlier, over the divisor. Number 2, factor the denominator and apply cases 1 through 4. One of those. All right, so let's go to an actual question now. The example is integrate (5x squared plus 20x plus 6 x cubed plus 2x squared plus x dx. So you can't start integrating right away. There is no u sub, there's no trig sub or part by parts. So you have to factor and see if you can make it better, and then see if you can you can factor it, yeah. Okay. The bottom has an x. I'm going to factor it out. It'll be x squared plus 2x plus 1 dx, which will be 5x squared plus 20. So that top part doesn't change. The bottom will be x times, looks like what? X plus 1. So similar to the one we did earlier. So I'm going to remove the integral and just deal with this for now. Let's decompose the fraction. So 5x squared plus 20x plus 6 is equal to x plus x times x plus 1 squared, which will be a over x plus b over x plus 1 plus c over x plus 1 squared. Do your multiplication, right? You're going to multiply both sides by this LCD. So all 3 sides so every single fraction, sorry. And then we're going to group the terms like we did earlier. So the first one, you lose the entire fraction. The entire denominator disappears. And then we go to the next one. We're left with x plus 1 squared times the a plus x times b, or bx, plus, well, actually, that's not right. You lose one of them, not both. And then this one knocks out both. So this is a CX. So then we expand all this and multiply, and then we will group all the pieces we need. So this will be, multiply that out, that'll be a times x squared plus 2x plus 1. This will be b times x squared plus x plus cx. That would be ax squared plus 2ax plus a plus bx squared plus bx plus cx. So then group everything together. That has the same power, the like terms. Ax squared plus bx squared go together. 2ax plus bx plus cx go together. And we have one constant to create the system, right? So I'm gonna do it over here. So look at the quadratic pieces. A plus b are the quadratic parts. What are they equal to? Do we have a quadratic on the left-hand side?
5.
5x squared.
Yeah, so we're going to use that 5. Now look at the x terms. 2a plus b plus c is equal to the x constant coefficient, 20. Now we look at the constant. Sorry, that's a first power, not constant. So then a will be equal to 6. So we already have a. If a is 6, what is b?
-1.
Yeah, and check it out, right? A plus b is 5. If this is 6, that means b has to be 1. So what is 12? If this is 12 plus 1 is 13,
Wouldn't
c
B
would
be
be,
-1, not 1?
yeah, I think he said -1. I just didn't write it right. Thank you. So 2 times 6 is 12, minus 1 is 11. So c would be 9, right? So you can kind of just do the substitution and solve it. If you prefer, you can create a matrix, right? The matrix would be what? ABC, so 1, 1, 0, because there's no C on the first equation, 5. Second one is going to be 2, 1, 1, 20. Last equation only has an A, so this is 1, 0, 0, 6. So you can solve this guy. Which will then give you, double check everything. 6, -1. Yeah, those are correct. 9, yeah, they're right. So once you have all those pieces, you can integrate. So we haven't actually solved the problem, have we? Okay. Let me write the question down one more time. Now we separated this stuff to, what was it? 6 over x plus negative 1 over x plus 1 plus 9, right? Over x plus 1 squared. Is that right? That's what we found for ABC, correct? Six, negative 1, 9. And we separate it this way. So plug them in and then integrate. So the question becomes the integral of 6 over x dx plus the integral of negative 1 over x plus 1 dx plus the integral of 9 over x plus 1 squared. So this first one is an easy one, right? And that's just going to be 6 ln, right? X plus, well, minus, right? Minus ln of x plus 1 plus. And this one I'm going to let u equal x plus 1, du is dx. So this will be 9 du over u squared. Okay, and this guy, you can bring that power up, right, using our log properties. Back in college algebra, this is going to be ln of x to the 6 minus ln x plus 1. This one will be 9u to the negative 2. So that'll be an easy one. Although we can combine these a little further. Since this is a minus, you can divide, right? Properties of logs. This will be minus 9u to the negative 1 plus c, which is ln of x to the 6 over x plus 1 minus 9 over x plus 1 plus c. You see how once you do the partial fractions, the integration is not too bad, right? It's just doing all that algebra to get your partial fractions. Is there any questions on at the beginning or in the middle? It doesn't matter. Does it make sense?
Yeah, I think so far. I just have to practice, I believe.
Yeah. A lot of the time they'll end up being ln or something. Okay.
The u negative 1 is because we subtracted 1, right?
Yeah, so it was negative 1 because you add 1 and then divide by the result. So you add 1 and divide by negative 1, which makes it negative. Right? Because it's going to be u negative 2 plus 1 over negative 2 plus 1, right?
I'm checking. I just want to make sure what I was
Okay.
understanding.
Yeah, you're right. Okay. Let's look at another one. Okay, integral of 2x cubed minus 4x minus 8 x times x minus 1 times x squared plus 4 dx, which is equal to, if we just do the partial fraction, this is the question, right? I'm gonna just erase the integral symbol. So the question is this up here. So the partial fraction needs to be done first. Make sure I wrote everything good. Yeah, so I went ahead and factored it ahead of time. Who cares? So distinct says we do A over the first one, B over the second one, and then this is a quadratic that doesn't factor, so that's EX plus D over X squared plus 4, right? Okay. So we're going to cancel the fractions and then start multiplying. So both sides are multiplied by this. The left-hand side always ends up with just the top part, but I'm going to try to show it. I don't know if I have enough space though. So this part, and then you do it again. Do it again. Yeah, I don't have space, but I'll write it down here somewhere. Do it again here. Times the CX plus D over X squared plus 4. All right, sorry, that's a little small or messy, but so that'll cancel, leaving you with 2x cubed minus 4x minus 8 equal to the x's will cancel, leaving you with x minus 1 times x squared plus 4, and the a. These cancel, leaving you with x times x squared plus 4. Last one cancel, leaving you with these two times cx plus d. Okay. So we're going to have to multiply all this nonsense out, which is kind of sucks, but oh well. So this will be x cubed plus 4x minus x squared minus 4, everything times the a. I forgot my b here. This will be x cubed plus 4x times the b. This will be x squared minus x times cx plus d. So then we get ax cubed plus 4ax minus 4, or minus x, oh shit, ax squared. distributed b. This will have to be a FOIL, sadly, so that'll be cx cubed plus bx squared minus cx squared minus dx. Okay. So we'll group everything that is the same together and create the system. So there's only 1, 2, 3 cubes. So the cubes go here. The quadratics go next. Ax squared, bx squared, cx squared. Now, the constants go, oh no, the x's go next. 4ax, I'm gonna start crossing them out. 4bx, minus dx. Yeah, that's all of them, right? And then the constant, it's just that one, I think. Yeah. All right, so let's make the system. So a plus b plus c is equal to 2 for the cubic term. For the square, minus a plus b minus c is equal to -4. Actually, 0, there is no quadratic. Okay. Cube squared x's. So 4a plus 4b minus d is equal to -4. And then the constant, -4a is equal to -8. Finally. Create the matrix, because there's no way I want to do this by hand. So the the A column, or the first equation row, that will be 1a, 1b, 1c, no d's, 2, 0, -4, -8 for the constants, -1 for the A, 4 for the A, -4 for the A, 1 for this B, 4 for the B, no B's. C column, 1, -1, no C's, no C's. No D, -1 D, no D's. All right. This one's a little algebra intensive, but the ideas are the same. So this is a 4 by 5. So 1, 1, 1, 0, 2. -1, 1, -1, 0, 0. 4, 4, 0, -1, -4, -4, 0, 0, 0, -8. All right, so the solution will be 1, 0, 0, 0, 2, 0, 1, 0, 0, 1, 0, 0, 1, 0, -1, 0, 0, 0, 1, 16.
I didn't think there was a bx squared.
No?
I think it was a dx squared.
Let's see.
There was a bx squared.
Square term. Talking about this one, right?
Yeah, that was from foiling the x squared minus x and the cx plus d.
Yeah, I think you're right. So cx cubed plus dx squared. Yeah, I wrote a b. Son of a bitch. Okay. D. So then this difference would be here. That's a D. Which would mean the quadratic one would not have a B. That would be minus C plus D, right? Yeah. Which would make this and make it negative 1, 1. Okay, so the answer is now BS right here.
The second row, B would have to be a 0 too. I'm sorry.
Second row. Oh, did it
It'd be
change?
negative 1, negative 1, 0, negative 1, 1.
Oh, right. Yeah, thanks.
Oh, yeah, sorry. Thank you.
Yeah, I want to make sure I get that before I punch it in again. All right, let's go fix it. So first one's good. Second one was the messed up one. Now we're good. So the answer should be 1, 0, 0, 0, 2, 0, 1, 0, 0, negative 2, 0, 0, 1, 0, 2, 0, 0, 0, 1, 4. So A is 2, B is negative 2, C is 2, D is 4. So we will now integrate, right? Replace all the A, B, C, D and start integration. So 2 over x dx plus negative 2 over x minus 1 dx plus the integral of 2x plus 4 over x squared plus 4 dx. Right? All right, so, oh, wait a second. Yeah, technically I can separate these two, right? Okay. I'm gonna go ahead and start this on another page. So that was 2 over x, right? Dx plus, I forgot, negative 2. All right. So the first one's no big deal, right? That's just going to be 2 ln x. Next one will be same deal, 2 ln x minus 1. You do a little u sub for this one, you end up with this. This one needs to be separated though. This will be integral of 2x over x squared plus 4 dx plus the integral of 4 over x squared plus 4 dx. Okay, so then that would be ln of x squared minus ln of x minus 1 squared. This one will be a u sub. So for this guy, let u equal x squared plus 4. Du will equal 2x dx. Du over 2 will be x dx. Well, actually, there's already a 2 there, so that'd be fine, actually. Perfect. I forgot. So this will be the integral of du over u. And that one's still there. Right. This will combine into x squared over x minus 1 squared. This will be ln of u, which is really x squared plus 4. Now we just need to integrate this guy. So using more logarithm rules, this will be x squared times x squared plus 4 over x minus 1 squared. Combining these two, this is actually what? Do you see it? Right, this is R10, isn't it? I'm going to rewrite this right here. So that will be, let's see here, R10. Hold up. I'm gonna double check my work here. Same thing. I see. Sorry, I was looking at the example and it looks like there was a mistake. Anyway, so this guy's gonna be arctan, right? This should be, let me look up the formula for arctan. So integral over this should be, no, that's not the one. Where is it?
It'll be 1 over A tan inverse. R10 over U over A plus C.
U over A, right? So, but isn't there a number in front that I'm trying to check for, or no?
You got 1 over A.
Looks like it's just this plus 4 arc 10 of x over 2 plus c. Double checking. I'll have my formula in front of me. Forget the arc10. I think there's a 1 over, you said 1 over A in front, right? So A is 2, so there should be a 2 there. So final answer is this nonsense. I'm running out of ink today. Okay. You guys getting the general idea though? You see how partial fractions make it a lot easier?
Yeah.
So the main thing is you need to remember, how do I do partial fractions? And once you got that down, you're just doing integrals from the beginning of the chapter 6, I think, maybe 8.1. So the integrals aren't bad. It's just you have to do a lot of algebra to set it up. You guys have any questions on partial fractions?
Just got to practice it.
All right. I guess we'll stop here then.